This is an A-level pure question on integration. So before we do this question, I just want to run through this notation here. So the first thing is when you see this rounded E like that, that just means in the set of. So it's about to tell you that K is in the set of a particular set of numbers, and the set of numbers that Z is in the set of are positive integers. Now the Z symbol, Zahlen, just means integers, and when it's got a little plus line there, it means that we're only dealing with positive integers. So K is only going to be a positive integer. And what we need to do in part A, we want to show that the integral between the limits of K and 3K of 2 over 3x minus K integrated with respect to X is independent of K. So let's do the integration and see what happens. So we've got K and 3K like this, and then 2 over 3x minus K. Now when we have an integration where if you were to differentiate the bottom, you get the right type of powers of X, but maybe the number doesn't quite match, then the pattern that we use is this: K, which is going to be a constant, times by an integration that looks like this. So basically the top of the integration looks like the bottom differentiated. That's going to be equal to K times by the log of the bottom, the f of x. And I'm using the modulus symbol here. Strictly speaking, we want to use a modulus because we don't want to do the log of a negative number. If you use brackets, you're not going to lose marks, but just be aware that the correct notation is to use modulus when we're doing the log of something, so that we always have a positive value here. Now you'll notice that it doesn't quite fit the pattern, so we're going to make it fit the pattern. This saves us having to try something and go back and make an adjustment. So if I differentiate the bottom, what would I get at the top? 3. So we're going to make it look like the pattern. So I'm going to write 3 over 3x minus k. Now it fits the pattern. However, I can't just change the question to a number that I want here because it's a different question. But I can put a k number, a constant over here, some number, to make sure that all of this altogether is worth the same as this. Now to make that happen, if I put 2/3 here, this has exactly the same value as this, because if I do 2/3 times by 3, it becomes 2. So these are worth exactly the same thing. However, this is in the right format for us to use the rule straight away without having to go back and make any adjustments, because the bottom differentiated, which is 3, appears at the top. So now we can just write 2/3 log of the bottom, which is 3x minus k. And if you've got time, what you can do, you can always go back and differentiate your answer just to check that it's correct. But this method will always work if you make the adjustment before. You can make the adjustment afterwards, but I just find this way a little bit quicker if you're confident. If you're not too confident, just do the method where you try log of the bottom here, you try log of 3x minus k. You'll notice the numbers are not quite right, so you'll need to introduce a 2/3 to make it all balance. Right, so our limits are k and 3k. So we'll put those limits in. So what we'll have is 2/3 log of 3 times 3k minus k minus 2/3 log 3 times k minus k. Right, let's do that and see what we get. So you get 2/3 log. So this is going to be 9k minus 1, which is 8k, minus 2/3 log, and this will be 3k minus k, which is 2k. Whenever we subtract with logs, we can put it together as a division. So it becomes 2/3 log of 8k divided by 2k. Now 8k divided by 2k is just going to be 4. So we end up with 2/3 log 4. Now this proves that the original question is independent of k, because it doesn't matter what value of k you put in, positive integer for k, you're always going to get this result here because the k's cancel out at this point. So whatever k was, doesn't matter, you're always going to get 2/3 log 4. So that proves that the original integral is independent of k. Part B, what we want to do is to show that the integral between the limits of k and 2k of 2 over 2x minus k all squared integrated with respect to x is inversely proportional to k. Okay, so just like the first bit, we are just going to do the integration of what we have been given. Right, so we've got 2 over 2x minus k, and that's all squared. This is going to be a different method to the first one, in that the bottom differentiated doesn't give you the top. So whenever you've got something like this, we're going to rewrite this and bring the bottom to the top and write the whole thing as power -2. So I'm going to write, and I'm going to bring the 2, which is the constant, over to the other side. It's just good practice to do that. It often makes integrations just a little bit easier. So the 2's been brought over, and the denominator I write as 2x minus k to the power -2 dx. I can now integrate this. I can use the reverse chain rule because the inside of this bracket is linear. When it's not linear, you can't use the reverse chain rule. So reverse chain rule to do this integration, so a different method to the first one. Okay, so I will have 2 times by what I will get when I use the reverse chain rule on this. So step number 1 is to integrate the outside. So to integrate the outside, I add 1 to the power and divide by the new power. So if I add 1 to the power, it's going to be -1. And if I divide by that new power, I'm going to divide this by -1. So that's the same as just putting a minus sign in front. So I've integrated the outside. The inside of the bracket, remember, doesn't change, whether it's the chain rule or the reverse chain rule. So 2x minus k. And then I divide by the inside differentiated. Now, if I differentiate the inside here, I get 2. So if I divide by 2, I'm going to cancel out this 2 here. So rather than write divide by 2, I'm just going to cross that 2 out because it's going to get cancelled out. And so my limits are k and 2k. So let's just tidy this up a bit. So I'm actually going to write this bit here as -1 over 2x minus k. Just going to be a little bit more straightforward to put the limits into that rather than the power of -1. So k, 2k. And now we can put the limits in. So I'll have -1 over 2 times 2k minus k minus -1 over 2 times k minus k. Right, so over here we're going to have 4k minus k, which is 3k. So I'll have -1 over 3k, then -1, so it's going to become plus 1 over, and then 2k minus k, which is k. So I want to put these together. So if I were to times the top and the bottom of the second fraction by 3, I would get 3 over 3k. So I'm just going to swap them around as well. That's the plus, and then minus 1 over 3k. So that's just going to give me 2 over 3k. And this last expression is inversely proportional to k as required. So I might just finish this off by saying A, so 2/3 log 4 is independent of k, and part B, this 2 over 3k is inversely proportional to k, because we have this k at the bottom here. So you could write here that this is the same as proportional to 1 over k, which is the inversely proportional bit.